Good morning, everybody. I hope you all enjoyed the inspiring keynote from Arman, and I'm excited to continue this momentum by diving into a topic which is very essential for scaling secure access. So I'm going to talk about how to empower credential injection at scale using HashiCorp Boundary. So before we start, by a quick show of your hands, how many of you still use SSH keys for authenticating to your SSH servers? Okay, I see decent number of hands raised. Not a very great news, but let's see how do we mitigate this problem. So before we dive into the main agenda, let's quickly take a step back and examine how SSH access is traditionally managed and what all different kind of challenges do you see at each step. So imagine a user who needs to access a target sitting in a private network. First of all, they would need VPN credentials in order to get inside the corporate network. So now this process often complicates the offboarding and onboarding of the users. Secondly, once they are inside the corporate network, they would have to configure their SSH keys on a Bastion host in order to access the private network. Now these keys are typically static, they are long-lived, rarely rotated, and not even revoked when the users leave their organizations, thus presenting a significant security risk. Once they are inside the private network, users often get more access than they need. And this is where the organizations try to bring in some kind of IP-based firewalls, which you see in the third step. Now these firewalls, they work well with static hosts, but with today's ephemeral workloads, managing them becomes increasingly difficult. And finally, when the user reaches the target, now they would again need credentials, which are static, long-lived, and they are often insecurely stored in notepads, Slack channels, team channels, and other password managers, again presenting a security risk. Now, if we see this workflow, there are several challenges in this workflow, but with any technology, right? I mean, if we have to move towards zero trust network philosophy or security philosophy, we definitely have to do something differently. And this is exactly where the integration of HashiCorp Boundary and Vault comes into play. So as some of you might know, HashiCorp Boundary is an identity-aware proxy solution which gives you a very simple and a secure way of accessing your host. And HashiCorp Vault is a comprehensive secrets management solution. So if we look into this workflow, in the very first step, the Boundary user uses a Boundary CLI or a Boundary desktop app in order to authenticate to the Boundary control plane using an identity provider which has been configured for your organization. Once the user is authenticated, on the third step, you'll see that the user would be presented with a list of targets or list of hosts which he's authorized to see. Once that user attempts to connect to that particular target, the Boundary control plane gets the requested credential from HashiCorp Vault. Now this credential can be again static, dynamic. Dynamic is better, definitely. And this credential is then injected or brokered to the Boundary worker, and the session is established to the target. So now, if you see this workflow, one of the key advantages of this workflow is that you are not bridging your clients onto a private network. So you stay in a line in a sort of zero trust network philosophy. So now this workflow addresses the challenges which we saw with the traditional SSH access. But with any technology, as with any technology, right, scaling and adoption of Boundary across large and complex environments has its own set of challenges. Let's quickly take a look on those set of challenges across different phases. So during adoption phase, you'll see that once the organizations, they start using credential brokering, the credentials are still being exposed to the users, right, even if you are using Boundary. And the other challenge what we see is that even after integrating Boundary with Vault, the organizations, what they start doing is they start copying their SSH keys and start putting them into the Vault KV secret engine. Thus defeats the whole purpose of zero trust security, right? And then during scaling, we often see accountability and traceability issues with shared user Linux account, or you might also see some kind of resource sprawl with multi-user Linux accounts. So we are going to understand about all these challenges and their probable solutions. And finally, when you are talking about thousands and thousands of targets, right, you often struggle with automating all these configurations. So I would like to mention that I have personally encountered these issues firsthand. Over the past couple of years, I have very closely worked with the Boundary product management team and several customers to scale and deploy HashiCorp Boundary in production environments. I mean, I have navigated through many of these obstacles, and this experience has given me some deep insights into both capabilities and limitations of Boundary, and I'm really excited to share all these learnings with you all today. So I would like to take a moment and introduce myself. I'm Japneet Sahni. I'm a cloud and DevSecOps architect at Arctiq with a deep focus on security and automation. I had the privilege of being a HashiCorp ambassador and contributing to Boundary as a core contributor. It's been an exciting journey to see this tool grow and evolve over the last 2-3 years now. And while I'm not working on tech, as you can see in my picture, I love playing with my furry baby Fluffy. She's a 10-year-old lab. It's indeed a great way to recharge yourself and explore new places together. So let's quickly go through the agenda. So first, we'll be addressing the adoption challenges in Boundary. We'll understand the passwordless authentication feature of Boundary. We'll see a quick demo. And then we'll address the scalability challenges in Boundary before summarizing our talk. So let's quickly jump onto the adoption challenges. So the first challenge being credentials still being exposed to the user. So organizations often using Boundary OSS rely on credential brokering feature, right? So with this feature, what happens is you basically lack the ability to hide the credentials from the user. So say, for example, if a user attempts to connect to a target through a Boundary desktop or Boundary CLI, in the very first step, you'll see that the credential is requested from HashiCorp Vault. That credential is returned back to the control plane, but now that credential is exposed to the user, if you see in the second step. The Boundary user, in that case, what he does is he copies that password and then uses that password in order to connect to the target through the Boundary worker. So even if you are using a dynamic credential, it still gets exposed to the user. So this is where credential injection comes into play. So as part of this feature, when a user attempts to connect to a target, the Boundary control plane again will get the credential, but now instead of exposing that credential to the user, the credential would be directly injected into the Boundary worker and the session would be established. And if you can see in the picture, the user's mind is literally blown away after seeing this passwordless authentication feature, which is very, very interesting. I would just like to mention that this particular feature is only available in Boundary Enterprise and HCP Boundary version of Boundary. The next part is, even if you now integrate HashiCorp Boundary with Vault, right, the static SSH keys are still stored in those Vault KV secret engine, right? Those are still scary, long-lived static credential at the end of the day, right? So how do we get rid of those credentials now? Now this is where exactly SSH certificates will come into picture. So with SSH certificates, the user's authenticity is based on a possession of a signed certificate by a signed certificate authority, which in this case becomes HashiCorp Vault. So now instead of provisioning and deprovisioning your SSH keys across infrastructure, now with SSH certificates, you can actually specify how long your certificate will be valid for, or which all users your SSH certificate holder can log in as. So if you see the workflow, in the very first step, the Boundary generates a SSH key pair and sends it to Vault, if you see the first step. In the second step, what happens is HashiCorp Vault signs this certificate and sends back to the Boundary control plane. And then finally, this signed certificate is injected into the target through the Boundary worker. right? So the only prerequisite in this workflow is that if you see at the rightmost side of the slide, you have to embed the public key of the certificate authority into your target to correctly configure your target now. So let's quickly see a demo on this feature, and this would literally make you blush, basically. So this is HCP Vault cluster. If you look back, so this is my secret engine. So this is the SSH secret engine, which we see here. So this is the boundary client SSH role, which you see here. And if we go back to the details of this role, you will see that the key type is set to CA, and the default username has been set to shared user. If you go back to the policies now, right, so you'll see the boundary controller policy here, and in this policy, you'll see that this policy is very important from an integration perspective of the boundary controller and HashiCorp Vault. So you'll see that we have given the lookup capability, the renew capability, and the revoke capability to this boundary controller. So if we go back to the SSH policy, now this sign endpoint is very important, right? So if you remember, the boundary control plane was generating an SSH key pair. So this sign endpoint is used for generating that SSH key pair on the behalf of the user. So now if we go back to the, so this is the vault configuration. Now the next thing what we have to do is configure our SSH target. Right, so if you remember, as part of our slide, we had to configure a public key of this certificate authority into this particular target. So now what I'm actually going to do is I'm just going to copy some commands, and we'll go through these commands one by one. So I'll just copy these commands over here. And if you notice in these commands, what I'm doing here is, first of all, through the vault, I'm trying to get the public key of that certificate authority. The next thing what I'm going to do is store this public key of that certificate authority into my SSHD config and store it in the trusted user key. Okay, and I'm going to restart my SSHD service. So now my SSH target is now ready. The next thing what we have to do is do the boundary configuration. So now I've already created a HashiCorp organization and a project. So in this particular project, the next thing what I'm going to do is create a credential store. So a credential store is, again, the concept in boundary which helps you in integrating or getting the credentials from HashiCorp Vault. So I'm just going to give a name to this credential store, and I'm going to select the type as Vault. Next thing what I'm going to do is I'm just going to copy the Vault URL. This is the HCP Vault cluster which I created for my demo, and I'm going to paste the token which has been created against the boundary controller and the SSH policy which we saw earlier. So now I'll just save this credential store, and now my credential store is created. The next thing what we are going to do is create the credential library. So now this resource is the one which provides the credentials, and in our case the credential is SSH certificate, which is going to be signed and sent back to the boundary. So I'm going to select the type as SSH certificates, and if you remember, this is the same endpoint or same endpoint which we talked about while our configuring the policy, the sign endpoint, and this username is the one which the certificate holder can now log in as. So this is a very important field which will again come back in our upcoming slides. I'll put the other useful extensions for my credential library and save my credential now. So my credential is ready. Next thing what I have to do is create a target and associate this credential with that target. So I'm going to create an SSH type of target. Now this type is very important. So you'll be able to see this type of target only with boundary enterprise and an HCP boundary. And that supports credential injection as well. So I'm just going to copy the address and save the target. The next thing I'm going to do is inject the application credential which we just created into this particular target. So I selected the credential, and there we go. So now everything is done. All now we have to do is authenticate and connect to this target. So this is the boundary desktop app. We authenticated first. Based on my authorized role, I saw a target. Once I click on connect, the credentials will be coming from HashiCorp Vault, the signed SSH certificates. And if we go to the embedded terminal, this is where you'll see that without even entering any credentials, I'm automatically authenticated to my SSH target, thus giving you a very good passwordless authentication experience with this feature. Okay, so what have we addressed so far? So we used credential injection for hiding those credentials from the users, and then we made use of dynamic SSH certificates for replacing those scary static SSH keys from the vault secret engine, right? Now let's address the scaling challenges. What different kind of scaling challenges do you get with different scenarios? So the first scalability challenge is the accountability issue when you are using a shared user Linux account. So from an organization's perspective, there may be some good reasons of sharing usernames on your host, such as making it easier to configure Unix permissions, resource limits, or maybe simplifying the overall provisioning of the host. Right? So if we look into this diagram, right? So let's take an example. You have a Linux machine with a shared user. It can be Ubuntu, it can be EC2 user. Now if I have different boundary users who are connecting to this particular machine or Linux host, it basically causes the accountability and traceability issues. Okay? So how do we solve this? So this is where SSH recording comes into play. So with SSH recording feature, every session recording is now going to be associated with a user. So you can literally go to that session recording, click on view, and play back that session and see what all commands that user had executed in that particular session, right? So, and it's also very important from a compliance requirements of an organization. So how do we do this? So first of all, what we do is we create a storage bucket. And this storage bucket is created with a given provider. It can be Amazon S3 or it can be MinIO, which can be used with any S3 compatible storage, right? The second step, what you need to do after creating a storage bucket is enable session recording at a target level. So once these two things are done, your configuration is complete. When the users, they start interacting with Boundary or start establishing sessions, you'll see when you go to the sessions recording page, now for every user, you'll see a session recording associated with it, and you can see all those sessions which have been executed on a target which had a shared user configured with it, right? So this solves your accountability and traceability issues as well. The second challenge being here is the resource sprawl with multi-user Linux accounts. So in the demo, we saw that while we were creating the credential library, right? So we had hard-coded the username in the credential library. Now, if you start hard-coding these credential libraries in the, the usernames in the credential libraries, and for every user you do that, you end up with some user-specific credential libraries. And then what you also have to do is create the same number of targets, because the target and the credential library mapping is 1-to-1. So if you have 100 users, you'll end up with 100 targets and 100 credential libraries. And this somehow creates some kind of resource sprawl within Boundary. So back in 2022, we were working with one of the financial institutions based out of Canada, and this is where we actually landed up with this problem where we started creating like hundreds and hundreds of credential libraries. And we then reached out to the Boundary product management team, and they actually solved this issue for us, right? And the solution was to use a dynamic credential library templating within your credential libraries. So now if you see here, instead of hard coding those vault paths and usernames in your credential libraries, now you can actually map these fields to the Boundary user information. So now you only end up with creating one credential library or maybe one target, right? Thus solving your resource sprawl. The last challenge is your struggle with automating your configurations. So if you remember in our demo, we had to configure our SSH target, right? So we had to add the public key of the certificate authority in our host. Now, if we have hundreds and thousands of such targets, it becomes very, very difficult to scale this, right? And also, you saw me creating credential stores, libraries, and targets manually in Boundary, right? But again, when we are talking about scale, this is not scalable at all, right? And you'll definitely struggle here. So how do we solve this? So this is where we use HashiCorp's own tool for solving these issues. So we can use HashiCorp Packer to create golden images with that public key of the certificate authority embedded in the golden image, and then can spin up your different VMs. And for the boundary configurations, you can use the Terraform provider for boundary to configure all the resources. Okay, so if we look into the example, this is the Packer JSON file. So you'll see that I'm setting the vault address as the environment variable. I'm using a shell provisioner within Packer for getting the public key and setting that public key as a trusted user CA key in my SSHD config. And then you create a golden image using Packer, and then you use this golden image to spin up your infrastructure. That way your public key is automatically embedded in every machine you want, right? And if you look at the Terraform configuration as well, I've highlighted two most important resources over here. The first resource being the boundary credential library for specifically dedicated for SSH certificates. And if you see here, I'm actually making use of dynamic credential library templating. If you see the username part over here, this is what we see here. The next is the boundary target, right? So if you see here, the type of the target is actually SSH. And I'm also making use of credential injection. So I've highlighted the credential injection. So this is the same credential which has been created at the top. And then finally, I'm also enabling SSH recording at this particular target. So I guess now we have addressed most of the issues. So we use SSH recording for solving the accountability issues. We use dynamic credential library templating for avoiding the resource sprawl. And then we finally made use of Packer and Terraform for avoiding for our struggle with the automating of configurations. So now if we have to summarize, right, so this is the boundary control plane. First of all, you enable dynamic SSH certificates on your vault side. The second thing what you have to do is use HashiCorp Packer to embed the public key of the CA and create your different SSH servers. The third thing you have to do is bring in Terraform for automating all those configurations, right? And then you also enable dynamic credential templating in those credential libraries, and you enable SSH credential injection just to hide those credentials from the users, and you finally enable SSH recording onto your targets, which will solve your compliance issues and accountability and traceability issues. So now this integration of HashiCorp Boundary and Vault, this introduces a robust solution for dynamically creating and managing your SSH certificates at scale. So you can actually follow my Medium profile. So I write a lot of blogs around HashiCorp Boundary, Vault, and other different tools. So I've written some blogs around the how to achieve zero trust security using HashiCorp Boundary and Vault. How do you avoid resource sprawl? So we talked about one of the challenges during our slides, right? So how do we solve this? And a very interesting feature around multi-hop. So do go through these articles. That's it from me. Thank you so much for attending this. You can actually reach me out on LinkedIn, or I'm here for next couple of days. I'll be happy to share my experience around scaling and adoption of Boundary. Thank you so much and have a great evening ahead.